So first, I would like to thank you for the opportunity to present here at the event. In this presentation, I will talk about some well-known terms and methodology when talk about good practices of development. I hope I can puzzle the content in this time. So I will talk about clean architecture, clean coding, refactoring, testing, what does this change in my code. I'm Kamila Santos, I'm backend developer at TM Digital. Here I'm my GitHub, LinkedIn, Twitter, and Instagram profile. First, let's talk about the concept of clean code. Clean code is simple and easy to follow, with isolated scope, easy to be tested, and well self-documented. Clean codes have a phrase format follower that is a great reference in good practice that says that any fool can write code that a computer can understand, but good programmers write code that humans can understand. Clean code needs to be consistent or write only what's necessary and in the clearest way. Scout rule and leave the code better than when you found it. Res up, refactor as soon as possible, and keys that say keep it simple, stupid. In clean code, we need to use names that reveal the intention, use pronunciable and searchable names, don't define names with what you find most beautiful or cute, follow the patterns, and choose a word by idea or concept. Clean code is obvious for other developers, and in clean code, we don't have duplicated code. And now we have some categories of code smells that is a complete opposite of the clean code. One category of code smell is the bloaters. Bloaters are code, methods, and classes that have grown too much, accumulating over time as the program evolves. In the bloaters category, we have a large class that is a class that contains many lines of code, methods, and fields. We also have the primitive obsession, that is the use string constants as field names and constants for code information. For example, user admin role with 1 in value. Bloaters also have long parameter list that when we have more than 4 parameters for a method. And then data clumps, that is parts of code that contain identical groups of variables, such as parameters of external configs that we have many times in the code and duplicated in other places. We also have the other category that is object orientation abusers. That is the incorrect or incomplete application of OOP principles. In this category, we have switch statements, code smell, that is a very complex switch statements or sequence of each statements. Other of the OOP abusers is alternative class with different interface. That is when we have 2 or more classes perform identical functions but have different method names and 2 or more places in our application. Other category that we have is the change preventers. Change preventers happens when if you need to change something in one place in your code, you have to make many changes in other places too. And it's broke very times your application. Dispensables is a category that says when something necessary and meaningless, the absence of which would make the code more efficient, easier to understand, and cleaner. In the dispensables category, we have 3 types of code smells: duplicated code, comments is a bad practice, and that's a code that is not more used. We have the other category that is the couplers. Couplers contribute to excessive coupling between classes or show what happens if coupling is replaced by excessive delegation. And now let's talk about refactoring. And we'll go through some refactoring technicals, which are many technicals when I will focus on the main concepts and some examples of some techniques. Refactoring is the process of changing a software system in a way that is does not change its external behavior, but has an improved internal structure or performance, or the code is more cleaner after refactoring. Technical debt is the famous "I will do it later" and never done. Cause of technical debt is lack of well-defined development patterns of a company, or not know the best practice, like clean code, for example. Delayed or never done refactoring. Lack of interaction between team members. Absence of documentation and testing and updating them. Business pressure sometimes. And when to refactor. We know what is clean code. We need to refactor, but when I will refactor my code. One time is good to refactor is during a code review, or when you are adding a new feature on your application, when you're fixing a bug, or when you go through the code and see the possibility of being improved and you can invest time in it, stop your work and refactor this code. And how to refactor a code. The new code needs to be cleaner than the previous one, so you need to keep the functionalities, but let the code more cleaner. New functionalities shouldn't be created during refactoring, just improve the functionalities. And we have some techniques of refactoring, as I say previous. One of these techniques is simplified method calls. That says this technique makes calls simpler and easier to use, modifying the interfaces for interaction. Other technique is composing methods. In this category, we remove code duplication, simplify methods, and prepare application for other future refactors. Organizing data helps with data handle and untangling of excessive class associations. Other technique is moving features between objects. That teach how safely move features between classes, hide implementation details, and create new classes. Other technique is simplify conditional expression and reduce and improve conditional expression, not use hundreds of if statements in your code. And dealing with generalization, move functionality along the class inheritance. For example, creating new interfaces and classes and replace inheritance with delegation. We have some technicals about composing methods. I will detail some technicals because there are a lot. And extract the method, we have a problem that is a method with more than one responsibility, which can be extracted for a new method. And here we have an example for a method print flow. And in this method print flow, we have a method print save that prints on the system the name, the values, and the pace. After the refactoring, you have the method print flow and have the other method print details that have the information. It's a simple example, but the idea is extract a method for another method and separate the responsibilities of them. Organizing data. Replace number with symbolic constant. Problem, you have a code that can be represented by a constant, and you can replace this number with a symbolic. Here we have this value, and we use the gravitational constant and replace it then, and instead of use the value many times. Simplify method calls, and we can replace the error with an exception. And for example, I have a problem that a method returns a value instead of exception. Here we have a method that returns 0. After refactor, I can return a throw new or the exception. On testing, I'm going to focus mainly on unit testing and JUnit, but we have many types of tests. First of these, let's present some concepts. Test Swift is a collection of test cases or specs designed to a test program for a specific behavior. Test suites are usually divided according to functionality of the system or the type of test performed. Test case shows the path taken by a module, use case, or functionality within the project. Unit test, you need to test each code functionality separately, each unit of it. JUnit is a platform for building and executing tests. JUnit platform discover test and test execution in JVM. JUnit platform exposes the test engine interface, which defines the execution contract for any testing tool on the JUnit platform. JUnit Jupyter contains the new features for building tests using JUnit and provides a test engine implementation for running tests written with JUnit Jupyter. And JUnit Vintage provides a test engine for running tests written in JUnit 3 and 4. Assert it is a useful method for determining the pass or fail status of a test case. Declaration methods are provided by org.JUnit assert class that extends the Java-Lang object class. We have several types of asserts. We have assert true, assert false, assert null, not null, and assert equals. Annotations is a special form of syntactic metadata that can be added to the Java source code for better readability and code structure. Here we have some examples of sample tests and math tests. JSON verified that JSON asterisk exact method except for spaces, strict false without escape characters. And here we have a test example for testing APIs that use web test client for Webflux, that we get an endpoint, search for an ID and expect that it returns OK. Here's the same thing, but I expected that return is not found, but this ID not exists in my database. And now some best practices for JUnit or other test frameworks. Standard test case names, for example, test sample service security order. Always try to make a statement for each test method. Don't pass the test just to pass it. For example, assert true is equal true. Use coverage and test report. Mock your data. Test only one unit of code at a time, and make it test independent of all others. Name your test cleanly and consistently. All methods, regardless of visibility, must have appropriate unit tests. And we have the famous param of test. In the unit, we have the unit, for example. In service, we have integration tests. In the UI, we have Selenium or tests exclusively or front-end. Finish the last topic of this talk is Clean Architecture. Clean Architecture is independent of frameworks. You can do it using any language, any framework, anything. It's testable. You can separate tests by use case more easily. You can test a use case. You can test a gateway. You can test other things more easily. Is independent of UI. You can use any framework on front end, any framework or back end, and you have many use cases that we don't have any problem in the communication integration. Independent of database, you can use Clean Architecture with NoSQL database, relational database. And now some definitions about some Clean Architecture components that you saw in the image. Let's explain the image. This is the Clean Architecture diagram. Clean Architecture is the famous concept for Uncle Bob or Robert Martin. And here we have the entities that are the enterprise business rules. We have the use cases. We have application business rules, interface adapter with controllers, gateways, and presenters. Sorry. And now we have these layers with the devices, web, database, external interfaces, and UI that are frameworks and drivers. Let's return. Entities encapsulate enterprise web business rule. An entity can be an object with methods or can be a set of data structures or functions. Use cases contain application-specific business rules. It encapsulates and implements all of the use cases on the system. All the logic of the application will be on the use cases, not in entities, domain, or gateway, just in a use case. These use cases orchestrate the flow of data to and from the entities and direct those entities to use their enterprise, while the business rules to achieve the goals of the use case. We have one use case for each functionality, but use cases can integrate for make other functionality. But business rules we have in the use case or entity too. But in the use case we have the logic for some math operations and other things that in the entity will be used. Interface adapters. In the example that I will show in the end of presentation, I use it to call of translators, but follow the image we call interface adapters. Interface adapters are the software in this layer is a set of adapters that converts data from the format most convenient from the use cases and entities. And interface adapters make the translation of a database object for a domain object or request to database or response to database and other things. He makes the role of adapter in the system. To the format most convenient for some external agents as the database or web, we also have API translators and database gateway to database repository and other cases of translators or interface adapters. And here an example is a more simple structure of Clean Arch, not the image that I saw in the beginning. In the example, I try to simplify Clean Architecture that is a concept more complex in the beginning. I have some difficult to understand this in the beginning. So this example is on my GitHub. You can download this, but I will try just to explain the infrastructure of this, not the features and other functionalities. So here we have 3 layers. We have the Clean Arch API, is the microservice or application. And we have 3 layers, that is the client layer, the domain layer, and the service layer. And here I will detail each layer. The client layer, we have the request package that contains the request of some request, and the response layer that contains response package, that contains the response, and the API package that contains the request and the response for some controllers that are in the service layer. The domain layer, we have the domain objects and some enums. So we have the database and we have domain objects. They have the same data sometimes, but in domain objects, we have just the names and types of what we will use in the application. In the service layer, we have more information. We have the config package. In the config package, we can have database configuration, cloud configuration. If you use config server from Spring Cloud, it will not exist. But in this case, we have database configuration, cloud configuration, external like web client or other request configuration. Constants that are some constants like endpoints, or some values that used many times in the application. Controllers, the endpoints of the application. Gateways that have the implement switch show to be sent to database, for example, and we have an interface in a class. The translators, as I say, is the interface adapters that make the translate of some object, for example, request to database, request to domain, and domain to database, and other. Here I make an example of the interface create event database gateway, And the classes that implement this, the create event database gated implement that contains all logic of make a insert on database, for example. It's a type of repository. And we have the translator, as I say, that create event request to event translator and create event database to event translator and event to event database translator. And the first is request to domain, the second is database to domain, and the third is domain to database. The last is the use case. Use case contains all the logic of the application, the implementation of a controller, implementation of other methods. All of this is the use case. The conclusion, let me drink some water. After all, I'll talk this. Separating this layer is not easy, but separating them from the beginning make the code more testable is the principle of Clean Architecture and easier to maintain. General conclusion of all the concepts that are present about clean code, code smells, clean architecture, refactoring, tests. What does this change in my code? These techniques, methodologies, standards are widely used and recommended. Among these technicals, Clean Architecture is the most difficult to implement, and it is worth considering the learning curve. And that radically changes our code to better, facilitate the maintenance and addition of new features in addition to integration of new tool members. And I forgot to say this, but test is a type of documentation. So a new team member that arrives in your team will read the tests and understand your system more easily. I finished it. But thanks for the opportunity. I hope you all understand what I need to present here. Here is my LinkedIn profile, my Twitter profile, and other social networks, example, and slides are in this QR code. And I will post on the chat the slides and the code example here.